Very good morning, dear students. Today we are going to explain closely coiled helical spring. And today in my class we want to demonstrate the theories behind the closely coiled helical spring. Basically we want to demonstrate the theory aspect. Okay. Now start. Here you can see the helical spring. Okay. And here at this point what you can see, there is a weight is hanging position. Okay, this position is in equilibrium. As the weight is there at position A, then the spring may not have any more deflection from its original position. That's why the position A is called as equilibrium position. Now just want to acquainted with various common terminology that are associated with this closely coiled helical spring. M, you know, M is the mass of the body. Okay. Now W, what is the W? W is the weight of the body. You know how we can find out W? It's very easy. W equal to M into G. Okay, you know it. All you know it. Now we are going to explain what is called stiffness. Stiffness is explaining as a restoring force per unit displacement. Restoring force. Restoring force means if you put force in these directions, okay, that is tensile force. You know that is tensile force. So what will happen? The spring will elongate it. Spring will be deflected from A position to it will come B position. Here you can see. And if the spring comes from A to B, what will happen? Spring again wants to come back on its original position, that is A. This force is called as restoring force. And A is called as acceleration of the body. A is called as an acceleration of the body. Okay. Now in this system, when you apply the tensile force at A point, when the body is in equilibrium, what will happen? There will be a periodic motion like this way, there will be a periodic motion. This body will be like this way. Now first, you know the force which you apply is the, according to the Newton's second law, what you know, M into A. What is M? I explain you, M is the mass of that body. Into A, what is A? A is the acceleration. A is the acceleration. It is called disturbing force. It is defined as an disturbing force. Why? Because the body was in equilibrium. If you don't put any tensile force here, the body will remain at its own position. You put the force and that's why the body comes from A to B. That's why the applied force A is called here as a disturbing force. Okay. So due to the disturbing force, the body getting an action that is periodic, simple periodic motions is achieved. And now what you can see, that it is a disturbing force. Very good. And now we come to the restoring force. And one thing I want to mention, that this stiffness in most of the books, if you follow, you can see sometimes and most frequently K is used as a stiffness. Okay, don't get confused. K and S both are the same. Most of the cases K is used. You can use K, but in our explanation we have considered it as A. Both are same. Okay. Now come. What is restoring force? How you can find out the restoring force? Restoring force is S. According to our notification, you can see restoring force is the ratio between S. What is S? S is the stiffness. S is the stiffness. I told you that A and S both are the same. Okay. So S is defined as the stiffness. So stiffness is the ratio of restoring force and displacement. You can see here restoring force divided by displacement. Now after applying the force, that is tensile force, what will happen? The spring will be under deflection. Spring will undergo two deflection. What is the value of deflection? We will explain. But the notation, that is del, we are using del to explain the deflection. Now you can see deflection can be defined as the ratio of force by stiffness. Force by stiffness. And what is the force? You know, m into g. Why m into g? Because understand, this force which is there, it is generated for which condition? It is generated for its self weight. It is generated the force which is attached here. Just imagine, there is a force is attached. The source of the force is weight of the body. This weight induces the force into the spring. That's why the weight means, I explained you what do you mean by weight? M into G. That's why I write down in case of force M into G. Understood? Why we write down force equal to M into G? Divided by stiffness, and we denoted stiffness as A, S. You can see as S. And here also explain. So you can see that del equal to mg by s. Del equal to mg by s. Now you can see m by s. So if you want to find out m by s, what will happen? Just g will come under the del. G will come in this side. G will come on this side. So this is the equation. Now there is few more equations. Say for example, if you want to find out the restoring force, this restoring force if you want to find out. How you can find out the restoring force? Restoring force is that how much load you applied here. Just carefully see this area. How much load you applied here. The body will again want to come back its original position. That means at position A, due to its restoring force. And so that restoring force can be equal, that must be equal to applied force as the come back to equilibrium force. That is called restoring force. As you applied the load, this same amount of force will be induced to the body to come back to its A position. That's why what we did, MA equal to S into X. How S into X come? That is restoring force. S is the stiffness. S is the stiffness. What is X? X is the distance. X is the distance. A to B is X distance, which the spring deflected due to the weight. So you know what is the restoring force? S into X. That means restoring force means again wants to come back to its original position. This B position, the body wants to come back to A. That is restoring. That's why S into X. And now you can see M into A. M into A, what is? The force you apply due to the load. And S into X is the restoring force. So from this you can find out M by S equal to X by A. Okay. Now come here. Now in simply harmonic motion, you know the periodic time is calculated through this formula, 2 pi root over of displacement by acceleration. It is very common formula for simply harmonic motion. And 2 pi root over of x is a displacement. From where we find out x? See the figure. This amount is a displacement. Divided by acceleration. What we denoted as an acceleration, follow. A is the acceleration. So x by A. Now you can see x by A. X by A can have the same meaning as M by S. So we can also write down in case of x by A equal to M by S. That we write down. Again follow. M by S can also be written by del by G. That's why we also M by S we write down del by G. These are the various ways through which you can find out the periodic time of this helical spring. Now come to the frequency part. Frequency, that is eta. through eta you can find out frequency, and all you know that in case of frequency it is the reciprocal of the periodic time. It is inversely proportional, or you may say reciprocal. Reciprocal is the right way to classify it. You can see 1 by Tp. What is Tp? Periodic time. So just alter this thing. See how you write Tp? 2 pi root over of x by a. See 2 pi root over of a by x. Just we shift these two. A at top, x at below. In this case, what we will do? S at top, m at below. G at top, del at below. See. At 2 pi was the multiply with these things, and when you find out the frequency, it will be 1 by 2 pi. As I told you, it is a reciprocal of it. Now this is the theoretical part of closely coiled helical spring. I think it is very much clear. Okay. Thank you very much.